Hey guys, I wanted to do a quick video about a recent project I did called, I'm calling it JFK RAG Adventures, but it was basically triggered by the JFK case files release. And I just like probably most devs who saw it was like, oh, let's do some cool, parsing and OCR on this. And so that's basically what I did. And I created this Colab, which is open source and you can check it out and I'll link it in the description. But I think it's a cool workflow to showcase the four stages for basically any RAG workflow, which I think if you understand that, it puts you in a really good position to do it for any other use case as well. And briefly, those four stages are the first, the document prep, which would be just fetching the data, parsing it. And then it would be the second stage is chunking. Third is searching, actually building the database, making it indexable, searchable, and then the fourth is actually the search. And so let's go through this example and to show highlight each of those stages. So the first was just obviously we're gonna install a bunch of packages and then we're gonna fetch the data, and you can use good old beautiful soup for this, and it's pretty simple to get this for archive.gov. They don't like block you or anything, and you can ask ChatGPT or one of the LLMs, just give it the source HTML and it'll do it. In this case, we first generate a list of PDFs. So let me just run this actually. So it should just generate a list, a text file with all the names of the PDF files on the website, and then we can fetch the PDFs one by one, and we can maybe, well, I don't want to ruin the state of this, but basically, if you run this, it'll fetch each one of these PDFs, and it'll take a while for that, probably like 10 minutes or something. And it'll fetch all the PDFs. So now you have all the PDFs in a folder, on your local system. Cool. So that's like part one of stage one. Part two is, okay, let's just parse the PDF. And we're going to use Mistral OCR for this. And I use Mistral because they have a pretty easy, intuitive, easy API to use. And they released it recently. And I have heard some criticism about their claims, and there are other options like Gemini, etc. you can use as well. But I just use Mistral because it was free. It's easy to get it up and going. So up to you what you want to use, and it really will also depend on your document, right? If you're doing some sort of a scientific like table layout parsing, maybe there's specific models or workflows you want to use for those. But in this case, we basically have this function which will go through each of those PDFs and then create it'll go through Mistral OCR, which gives back a JSON output, which has basically all the text and the images, etc. It also does actually it'll create parse all the images as well, and will give you back base64 formats for those images, which I think is pretty cool. And you can then reassemble that JSON into a markdown file, or just get a text file. So in this case, we'll just do the text file, and we'll clean it up a bit, using formatting and stuff, and it'll give you all the text files of basically the PDFs. So now we have we're done with stage one, which is just getting all the JFK files of the 2025 release, and we've parsed them and we have the text. So now we can move on to chunking. Now, what is chunking? So chunking is actually a very crucial element in RAG, and I actually think it's actually what broke RAG. It makes or break RAG, and in a lot of cases it broke RAG, because you don't just like throw a whole document into your database and just search it, because it's just too big. Usually there's a trade-off of size, in terms of speed and performance, and quality, because the bigger chunk is, in this case, the more information you can save it. The problem with chunking is, and the example, like in this case, what we do is we basically do the most naive form of chunking. We take the document and we do 512 character chunks. We just split it up into these chunks. The problem is, like, you can imagine that, if we're searching and we have this core insight that's in, maybe half of it is in one document, the other half is in another, it might not even come in the search results because of the way it's split up. So there's like the chunking is like not smart in this case. There are better forms of chunking, which is like context aware chunking, which you can create a summary of the page or the document and then attach that to your chunk, and that gives it some sort of wider context of where that chunk exists in the whole database. And so people have been exploring different avenues and stuff. So just be aware that this is actually a pretty crucial step that you should think about a lot, and it will come down to your particular documents and workflow as well. In this case, we basically do the bare minimum, which is like the simplest one, where we just divide it up into 512 characters. And well, this is sorry, this is these are just some high level statistics. You want to analyze the documents just to see what the most common words were, etc., and get some bar charts going. But then we can I'm going to come back to that in a second. You can like then chunk it up into those chunks. So that's the chunking part. And then we can move on to the database part now. And the database part, I'm using in this case Pinecone. And the I actually do want to say that even though I'm using Pinecone here, I do actually don't recommend them. And it's weird because Pinecone is, I mean, it's cool. There are cases where vector databases make sense, and and Pinecone in particular, I like their API. They make it very easy to get up and going. They have a free tier, not that generous, but it's free, so that's why I use them. I particularly like to use, if I'm a relational DB guy, so I like to use PGVector in Supabase or a PostgreSQL instance. I think that works for most cases, but it comes down to your use case and how big your documents are and how fast you want your query to be. So vector databases can make sense in that case. Just be aware, particularly for these VC-backed SaaS companies or VectorDB companies, they will get you in and then can charge you a lot if you scale, with scale. So just do that cost-benefit trade-off when you are setting this up. In this case, we're just doing a quick experiment, so I didn't think too much about it. And Pinecone, like I said, their API is nice. What you do is you create an index, which is their DB. In this case, we're calling it JFK index. It's stored in US East 1. And one particular thing I want to talk about here is embeddings. And we're using the sparse English V0 embedding. And this is an inbuilt Pinecone embedding they have. Now, when it comes to embedding, and this comes to kind of we can talk about stage 4 here as well. There's an overlap, but there's like a few types of searches. In particular, I want you to think about search as a spectrum on with two different extreme ends. One being keyword search and one being semantic search. Keyword search is what you'd expect, right? You type the word where and it'll just pull up all the documents that have the word where in it. That's keyword search, and for the longest time that was the search we had. And then around 2013 we had this things called embeddings, and it started with word2vec and glue, etc. And we found this interesting relationship where we could take words and convert them into vectors, and we could then use math to actually find similarities between words. There were some interesting relationships, like you can take the word king and you could subtract the word man from it and it would actually give you the word queen. So very fascinating, results. And this has led to this whole new space of semantic search where you can actually, search using meaning. So, you could ask for, if you had some document, let's say, and you were like, oh, who was the head of state in France in 1700? Let's say your documents had that, but they didn't have the word head of state. They had president. Because of semantic search, keyword search would fail in this case. But because of semantic search, it would probably find you that document because the word president and head of state are very similar and so that's the magic of semantic search. The problem with semantic search is actually that it can what is similar and what is not similar is not one thing. It really depends on your data, right? And so there's ways to attack it. You can train your own embeddings, etc., on your data set, or you can, what most people do, which I think it's a good baseline production, is you do hybrid search where you can weight those two searches. You can take keyword search and you can take semantic search, do both, and then assign some weight. So maybe 0.6 semantic search, 0.4 keyword search, and then re-rank the vectors using those weighting, and then give a final search rank. And that works pretty well. Supabase calls it hybrid search. In Pinecone, there's lexical search and semantic search, and you can go either way. Or in this case, I stuck with lexical search, which is their keyword search, because again, this is where your use case is so crucial, right? With the JFK files, people are probably going to be searching for specific words like Oswald or JFK or a particular place, Texas, whatever, right? And so keyword search makes more sense. So we want to lean towards that. That's why I picked that in this case. Um, and Speaking of embeddings, one thing I want to add on about embeddings is OpenAI came out with this new concept called Matryoshka weddings. Matryoshka weddings, embeddings, not weddings. And this is based on the Russian doll Matryoshka, and I think this is basically the way you want to do embeddings these days. And the idea is that where is that doll? God damn it. Yeah, you in the Russian doll, you have the doll, and then it gets smaller when you take the first case outer covering off, but it's the same doll, and that's the same thing with the embeddings. Embeddings, what happened was everyone had their own size. So OpenAI would have a 3,000 length vector, Gemini would have whatever 1,000, and it was annoying. And so OpenAI came out with this embedding format where they said we'll give you two vectors, 1,500, 3,000, whatever, and but you can take the 1,500, you can just slice it down to 768, 512. You can actually do it in any length, but in reality you want to stick to one of these lengths because they work, and their powers of two somehow they just always like work better for some reason. It is what it is. And so you can like go down and it'll pick your ideal embedding size. Why would you want to go down? Why not just pick the largest embedding? Because the more the embedding is, the more information is stored. Well, because it's expensive to store that embedding, and then doing search on a 3,000 length embedding is just a lot more compute intensive, and it might make your application laggy. So you probably want to do a trade-off. And I picked 256 because I want something fast, and keyword search in particular doesn't require crazy embeddings. And so I picked 256. So this, again, you want to play around with the exact size of your embeddings. So that's, and now we're now getting to stage 4, I guess. And that is the search part. We talked about embeddings, we talked about index. We have our namespace. We have written Pinecone. That's just what a Pinecone specific architecture. But once we have that, our chunks, which we talked about, we can then embed them using Pinecone's embedding, and then upload those chunks. And this will take a while. It actually takes like 2 to 3 hours, I think, here. But you can upsert those records, using this. And once you have those, you basically have a searchable database for your JFK case files, right? We've chunked them and we've embedded them and we've uploaded them. So now we got all these rows, and here it's a VectorDB, but you can imagine it'll be if it was a Supabase instance, whatever, we would do an embedding. We would create an embedding in a column, and we would actually have a embedding for the full text search as well. Like we embed that as well. It's a weird like container thing where they create these buckets of like how many words are counted in that particular document, etc. But we have those embeddings then, and as two fields in a row, we insert that, and so when we search, we'll just use those columns. And what do we use, like to show an embedding is close to another or far from another? We usually do either a dot product or a cosine similarity. There are other probably fancy metrics as well, but those are the two most common ones. TLDR on that is, dot product is faster, cosine similarity gives you more of a better quality matching, but it's a little more it requires a little more compute. And so I think the theme is to just be fast here, so we did dot product here. And we can see how we queried it here. Like we can just just do a search records, inputs text, we pass Soviet here, and we got these documents back. So in this case, I mean, this was just like a very small database, so we only got one back. But yeah, this is the full flow. We parse, we fetch the BDS, we parse it, we chunk it, we create a Pinecone index, we embed our documents, we upsert them, then we search them. And under the hood, when you search a word, like think about what's supposed to happen. You're supposed to take the text, you're first supposed to embed that word into an embedding, right? And then you do your dot product or your cosine similarity with the database. You find the closest records and you retrieve them. That's the full flow. That's the full RAG flow. So now you know how it works. And as a bonus, because I'm a front engineer, and front engineers, we say it's not doesn't matter what you are on the inside. What matters is how pretty you are on the outside. You want to put some lipstick on this pig. And so what I did was, I basically, once I had my database set up, I did where was it? I like created a nice UI where you can search those files. So you can say world, please work, and I hit my API rate limit probably. Jeez. Okay, that failed. It's likely because I hit the rate limit. Is it? No. Let's refresh. Oh, come on. God, see, this is one reason I hate Pinecone, because they have this ridiculously low free tier. But makes it easy to set up, right? That's just how it is. You gotta trade off ease of setup with how it's gonna scale. Come on, Oswald, give me Oswald. Give me something. Anyways, hopefully if you get to try it, it's on hackyexperiment.com micro-JFK. You will see documents. But oh yeah, there we go, finally. All right, and then you can pull up the markdown PDFs as well. But yeah, this is just making a nice UI out of it. But under the hood, it's basically the same stuff I was saying. It's just doing this and retrieving it from an index. So that's the full flow. Hopefully, you found that valuable. And I'll see you guys in the next one.